subtract x cubed y equals 6. Okay, I say this a lot. We're not doing this problem so you can ever do it again, or even anything like it. We're just doing the problem to represent concepts you must understand, flashcard, and memorize. Nothing I'm about to explain to you is new. Okay, so for the next 30 minutes, nothing will be new. It's like either things we learned in Unit 1, or it's things you learned prior to this class. But in this class, the next test is an AP test. It's 25 AP questions. So you don't have any idea what they're going to ask you. So don't copy what I do. Like, make sense of the concepts so that you can use them in all kinds of different places. The first concept is really simple. They give you an equation with an x and a y. You can use that equation to find any point on the curve described by that equation. So without a computer, it's really difficult to sketch what this might look like. So just kind of draw whatever, I don't care. This is how you find all these points. Okay? Question. That concept you must understand, flashcard it, memorize it. You have an equation, it's how you find the points. That's it. So that's not new. The question says, find all points on the curve. So we're trying to find all the points on that imaginary curve whose x-coordinate is 1. Just trying to find the points that have an x-coordinate of 1. So all we have to do is use the equation to do that. So take the equation, plug in x equal 1. So we have x, y squared, subtract x cubed y equals 6. We plug in x equal 1. So we have y squared, subtract y equals 6. Okay, next big concept. You're trying to figure out what y value will make this work. Okay? It's just the value of y that makes this true. Just trying to solve that equation for y. You need to memorize that you need to recognize that what you see here is a quadratic. You do not solve a quadratic by isolating y. You solve a quadratic by factoring. So you move over to 6. And then you factor. Question. Okay, so two separate concepts here. You will encounter problems in the future that will use one of these concepts, not the other. That's why you shouldn't memorize this problem. You should understand and memorize the concept. Concept 1, I have an equation for a curve. I can use that equation to find any point on the curve. If I'm trying to solve a quadratic, solve by factoring, not by isolating. So two concepts you have to know. Both of those will show up on the next test for sure. Questions? Please. So quadratic always has a really familiar look to it. It's going to be things like this. So that's a quadratic form. Does that seem familiar? Okay. Super, Justin. Anybody else? Oh, please, Abby.
So for this problem, there would be two points at x equals 1.
Correct. We figured out that.
-2 and 1, 3.
Mm-hmm. So the curve doesn't look like this. The curve is not a function, it's a relation. So it somehow does something like, I can't even draw it. It doubles back on itself somehow. So there's a point at 1, 2, and another point at 1, -3. questions on understanding what we've done so far? Please.
How do we know it was y, or I mean 1? Is it because it just says the x coordinate is 1, and then so our y coordinates are the ones y plus?
Say it again.
Like, how do you know that your x coordinate is going to be like 1, and then the y's are like close to that? This would be like negative 2. You know what I mean?
I think so. If I don't answer this, keep asking though. So we know the y coordinate is 1 because they specifically said, go look at when x has a value of 1. So I know this is the equation for finding any of the points. So I took the equation, replaced x with a value of 1, and said, like, look, the key idea here is you have an equation. There's an infinite number of xy pairs which will make this equation true. That list of infinite xy pairs, if graphed, becomes what we call the curve. They're asking us to focus on just one value of x, 1. So we plug in the 1. And we've got to see what y value will make this true. By factoring, it becomes obvious because we have two things multiplying. So if y has a value of 3, this would be 5. This would be 0. So I don't really care about this because 0 multiplied by 5 would be 0. So y equal, so I messed up here, hold on. This should have been the other way around. So if the y value is positive 3, this is a true, and the x value is 1, this is a true statement. If the y value is, sorry, if the x value is 1 and the y value is negative 2, this is also a true statement. Does that make sense? Don't memorize 3 points for Sydney. Hey, everybody look at the board. Everybody look at it. Don't look at this and say, oh, it's the opposite. That will cause you to make a mistake. Look at this and say, I have two things multiplying, and the result is 0. So therefore, I need to find the value of y, which will make one of them 0. Like memorizing the opposite, they'll fool you. Like they'll do something different, and it'll mess you up. The key concept is, two things multiplying, the result is 0. You need to find what value of y will make it 0. Anybody else? Oh. Oh, please, wait.
So can you give an example of like when it wouldn't be the opposite?
Okay, listen, please. So here's an example. So raise your hand, everybody. Hey, what values of x will make this true? Hands up. So what values of x will make this a true statement? What values of x will make this a true statement? Okay, everybody. Let's go, Tori.
2.
So if I plug in x equal 2, this would be 5.
Oh, I thought we were talking about the whole thing.
Oh, you're good. This would be 5.
Then I.
But this would be 0. So x equal 2 is definitely a solution. But I wouldn't think of 2 as being the opposite. Like I think some people would choose negative 2. But it's not, it's positive 2. How many saw this one? Point, 2 for Tori. This one's a trick because there is no value of x here that will ever make that 0. So you don't want to say negative 1, that doesn't work. That's kind of what I'm talking about. Does that help?
Yeah.
Please.
Could you say I? I would make that A.
Imaginary, yes, but for our class we do just only real numbers.
Oh.
Yeah. Are we good?
Again.
Good. Are we good to hear? Okay, look. emphasize again, the point here is not to solve this problem. I'm trying to give you some tools, concepts that you're going to use to get through the packet. Okay? There's not a problem like this in the packet. There's problems that use these concepts, but not this problem. So, first big idea, use this equation to find the point. Quadratic, you solve by factoring. Everyone good to there? Okay, next thing. It says write an equation for the line tangent at each of these points. Here's what we mean by that statement. Here's a point 1, 3. At that point, you can create a line. The line is known as the line tangent. This line has an equation. You'll need to memorize the equation. Any line can be written in this form. Okay? Now look, this equation has an x and a y. The reason this equation has an x and a y is because the equation is how you find all the x's and y's on the curve. This equation also has an x and a y. It's because this equation is how you find all the points on this line. So two separate equations. One for finding all the red points, one for finding all the purple points. Question? Cool. In this equation, you need to memorize that the m represents the slope of the line. x1, y1, they represent a point on the line. The x and the y are just like the x and the y here. They're used to find any of the other points. Okay? We need to talk through that again. So, two equations. One equation for finding all the points on the curve. A different equation for finding all the points on the red line. Hands up, points for this. How many different tangent line equations could I write for this curve? Looking for hands? How many different tangent line equations can I write for that curve? Hands. Sarah? How many knew that it was infinite? Point, 2 for Sarah. I can create a tangent line at any point on this curve, anywhere. So this problem is saying, hey, write this equation for the red line, but also go write this equation for this green line. So we're supposed to write the equation for both of those lines. Both lines will follow this same template. The m and the x1, y1 will be different. That's all. Please.
So that equation will y then x is that for tangent slope. Slope
2 for Justin. Everyone memorize the following. Be very, very careful when using the word tangent slope versus the word tangent line. Those are related, but they're different. So this equation is good for any line. Okay, any line. So I can use it to write an equation for this tangent line. I can use this to write an equation for this tangent line. Is that your question? Good. Please.
So you need to find the derivative to find the tangent slope out.
So the next big idea, 2 points for Abby, is this. We have this equation, right? We can find the derivative of this equation to create a new equation. I'm going to show you the steps in a minute, but here's the big picture. So I take this formula, I find the derivative. So now you've got 3 equations to keep track of. There's this equation. Hands up. What's the purpose of this? Come on, hands. What's the purpose of this equation? Carson.
to find any point on the F.
Perfect. Is to find any of the points on the curve. So we use that equation to find all of these points. How many knew it? 2 points, 3 for Carson. Look at this equation right here. Okay, we haven't filled it out yet, But once we have the specific equation for the red line, what's the purpose of that equation? Hence, once we have the exact equation for this red line, what would be the purpose of this equation, Kennedy? To find the points on the red line. How many knew it? 2 points. 3 for Kennedy. Then Abby said, we're going to find this equation. The purpose of this equation is to find every slope of the curve. So we go back to here. We can find the slope anywhere on this curve using this equation that we are about to find. Wait, if you need me to repeat that. So this equation, which we haven't found yet, you can plug in any x, y here, and that equation will tell you the slope of the curve at that point. So that's not new either. We mentioned that a lot in Unit 2, that's what we were finding with the derivative. The derivative is a formula. So, look, don't ever say this. The derivative is the slope. That's true, but it's too lazy. It's going to cause you to make a mistake. The derivative is a formula right here. The derivative is a formula for finding the slope, not the slope, because the curve has lots of slopes. So this is a formula for finding the slope. Questions? Okay, so let's go through this. You're going to need this in your notes. Step 1, you take the derivative of both sides. Let's cover up this so it's not so overwhelming. So this is not new again. This is exactly what you did on the test. When I take the derivative of both sides, I'm going to use the add-subtract property and then the product rule. So this one, using the product rule, becomes these two. So it's the second y squared multiplied by the derivative of the first plus the first, that should be x, x multiplied by the derivative of the second. Questions to that? This is not new, this is just Unit 2 stuff. Then I subtract, and I do the product rule again. So this one ends up being these two. Using the product rule. The derivative of 6 is 0. So here's this one. Just letting you catch up. Questions? This is why, like I say, if you have not scored 79 or higher on test 2, you cannot do Unit 3 until you get that fixed. Like, this packet's going to ask you to do derivative after derivative after derivative. Justin?
How does 6 become 0?
So what is the derivative of any constant all by itself?
Yeah.
Point. Good question. 2 points. Anybody else? Question for the whole room. Why are these parentheses essential? For hands? Why are the parentheses absolutely required? Let's go, Mary.
Because the negative has to distribute to the whole.
Perfect. It says subtract. I knew this was going to become 2 terms. Therefore, I must have the parenthesis because the negative will distribute. How many knew it? Point 2 for Mary. How many need me to talk more here? You ready for the next step? It's just what we did in Unit 2. So this becomes 1. This will become 2y y prime. This will become 3x squared. This is just y prime. Just wave if you need me to show those again or give more detail. So here, the x dx is 1. This one I'm going to bring down to 2. So I have the x. I bring down the 2. And it's y. The new exponent is 2 subtract 1. And then I have to multiply by dy dx. because I was taking y squared. Good. This one's quicker because it would just be 3x squared dx dx. This one's just y prime. Anybody else? Just looking for waving. I did what Marin said. I distributed the negative. That got me to here, step 3. Watching the pencil so I'm not going too fast. Cool. Do a little algebra. So I'm moving the y squared to that side. I'm also going to move the 3x squared y to that side as well. Wave if you need me to talk more about 3 to 4. Nothing new here, just reviewing Unit 2. Cool. Now we're going to factor out the y prime. So right here, we're going to factor out the y prime. Wave if you need me to talk more about 4 to 5. Please.
Can you talk about 3 and 4? Which ones did you move?
So when I looked at 3, what I noticed as I have 1, 2, 3, 4 terms. 2 of them contain y prime. So I leave those alone. The other 2 I move to the other side of the equation. 2 points.
Can you repeat that?
So my goal is to get, remember the goal is to get an equation for y prime equals whatever. So what I noticed right here is I have 1, 2, 3, 4 terms. These 2 terms contain y prime, so I want to leave those alone. These 2 terms do not, so I'm going to move those to the other side.
Okay.
Point. Anything else? Factor out the y prime. That gets you to step 5, and then divide. Please.
So I got this wrong on the test, but do you see like the x, y on the bottom and the x squared y on the top? You can't factor those out? What can?
You want to do like divide them?
Yeah.
You can only divide if the top is in factored form and the bottom is also in factored form. When I look at the top, what I see is something like this. I see this being added to negative this. So that's not factored form. So I don't want to divide. Only want to divide when I see the numerator as being something like this or something like this. And then the denominator as well has to be in factored form. Is that your question?
Yeah. I don't really know how to like ask.
You're okay. We'll just keep going.
Okay.
Okay. Chris?
Yeah, on the bottom, is it 2xy minus 3x squared, or is it multiplied negative 3x squared?
There.
Yeah.
You can either think of it as 2xy minus x cubed or 2xy plus negative x cubed, but they're not multiplying. If they were multiplying, you'd have to do something like this. Point, 2 points. Anybody else? Okay, hands up. What's the purpose of this equation? Hands. What's the purpose of this equation? So, Koji?
Find the point on the tangent, point on the tangent
Everyone look at me. Everyone look. Okay. What Koji said is incorrect, but I'm paying him, take 5, mark him down. For really a golden mistake. Look at me. That's really a common misunderstanding. This is not for finding any points on the tangent line. This is actually not for finding really anything on the tangent line. So, but it's commonly mixed up. This is not for finding points on the tangent line. What's the purpose of this equation? Hands. What's the purpose of this equation, Michaela?
Is it the formula to find the slope?
Perfect. So we started with, if you keep track of where things are, come on, if you keep track of where everything's coming from, it helps. We started with this equation. Purpose of that equation, find any of these points. We take the derivative of that equation, that gets us to here. So we haven't done anything with tangent lines. This is the formula for finding the tangent slope anywhere on the curve, not the tangent line. This goes back to what I said to Justin. Keep the word tangent slope separate from tangent line. This equation is how we find the tangent slope anywhere on the curve. Questions? How many knew it? Only 2 for Michaela. We need to restate anything. So this equation here is how you find any point on the curve. So any of the xy pairs. This equation is how you find any slope on the curve. Everybody with me? Good. Okay. So I'm going to take this equation. Let's go to a new page here. So, Sydney, just read that to me again. Y prime is what?
3x squared y minus y squared over negative 2xy minus x cubed.
Say it on the bottom again.
Oh, negative 2xy minus x
I
cubed.
think this is positive, right?
Oh,
Yeah.
just kidding. I have that written down.
Don't worry. So 2xy.
Minus x cubed.
Okay, put this in your notes. Okay, we're going to go to the point. What was it? 1 comma
3.
3. We're going to go to the other one, just for, so 1 comma negative 2. So 1 comma negative 2. We're going to plug that in. Look. 1 comma negative 2. So 3, 1 squared, negative 2. Okay, a habit you should develop right now is every time you replace an x or a y with a number, use a set of parentheses, and you will never make a mistake. If you do it without the parentheses, I guarantee you'll make mistakes. So when I replace the x and the y, I always use a set of parentheses. It prevents a very common error. Just put in parentheses, you won't make the error. So now just do the arithmetic. So let's see, this is going to be negative 6. That's positive 4, that makes it negative again. This is negative 4. So I get negative 10. Divided by negative 5, I get positive 2. Question? Okay, as always in calculus, it's not doing the work that gets you a good score, it's understanding the work. So what have I found? What does 2 represent? Hands. What is the 2 representing? What does the 2 represent? Do not lose track of what it means. Charles, sorry. Perfect. So I look at my picture. I've got this point on the curve at 1 comma negative 2. I've determined that the slope right at that point is 2. How many knew it? 0.2 for Charles. So, back to here. my drawing was a bit inaccurate. There was some point. The point is 1 comma negative 2. There's a line that goes through that point. The slope of that line is positive 2. So the equation of that line is 2 parenthesis x minus 1 plus negative 2. Okay, so we've got several equations here you've got to keep track of. We had the original equation. Read that to me one more time, Carrie. What's the original equation?
X1 squared minus X cubed Y.
Good luck. Focus. Don't check out yet. This is the equation for finding any point on the curve. Then we found this equation, which can be used to find any slope on the curve. We then used the line template to write an equation to find any point on this red line. So 3 separate ideas. Very good. Please.
Wait, can you repeat that again?
So this equation is how we would find any x, y. Don't leave at the bell. Stay with me. Got to get a little bit further. This will find any x, y on the curve. This will find any tangent slope on the curve. This is the equation for finding any point on this red line. So a completely different line. Everybody with me? Okay, one other thing that will show up in the packet is they use the word normal. Normal means perpendicular. Don't leave on the bell. It's really easy. So right here, there's another line I could create. Like that. Okay? That line is easily written because it uses the same template. So it still looks like this. Don't leave. Still looks like that. But because these two slopes are perpendicular, they are negative reciprocals of each other. So the line normal looks like this. That's the equation for finding any point on the blue line. Okay, the line normal. Good job, see it.
So the normal line just puts the slope.
The only thing that's different is they both go through the same point. So you notice these are the same, but the slopes are negative reciprocals of each other. Okay, not a new idea. Stuff you learned elsewhere.
So is the red line
So red line here, a tangent line. Keep going. You're doing great. So like this, Garrett. So this curve, I don't know what it looks like, but it has an infinite number of tangent lines. I'm just drawing the tangent line that goes through that point. So now with this equation, I can find any of those red points. Good work. So normal means perpendicular to the tangent. So I have the curve, Elena. I have this point one coming in. I can draw a line that is tangent to the curve at that point. I can create an equation for that line. So this equation is how I try to do these points. I could also draw a line that is more long. Well, it's easy to create that equation because same point, those are the same, but the slope is different.
It just makes you
It's just a negative reciprocal of that.
This is on a ranch.
The idea is that we have a curve. Anywhere on the curve, you can say, hey, let's draw a tangent line. So we just happened to go to this point because they told us to. We drew a line that's tangent. And then we wrote the equation of that line. Because that line goes to the point 1 comma negative 2. And we can find the slope of the red line because we can use this formula here to find the slope of the curve. So now we know the slope is 2. Well, if you draw a line that's perpendicular,
Got like a tiny like callus.
the slope of the perpendicular line will be the negative reciprocal.
But then the X and Y coordinate is still the same.
Same
it's a
point,
different spot.
going through the same spot.
Okay.
Now, if I move somewhere else, it's all going to change, but it doesn't change the concept, just the numbers.
Okay.
Wait, Christian, what's a reciprocal?
Say again.
Reciprocal, what's that?
So here's examples.
Thank you.
You're welcome. Good job, you guys. So if you find a tangent slope at some point has a value of, in this case, 2,
Yeah.
then the normal or perpendicular slope, normal means perpendicular,
Yeah.
will be negative 1/2. Because this was 2 over 1, reciprocal means flip, make it negative.
Okay.
If you started here with a slope of negative 2/5, the normal slope would be positive 5/2.
Okay.
Is that your question?
Yeah.
I forgot to give back.
Oh, you're fine. Just put them at cheerleading. Good? Good job.